Hello everyone, welcome to the world of STEM. I'm Amrit Vignesh, and today we're going to be going over factoring quadratics, which is an algebraic topic that you learn in mathematics. So we're going to do a quick overview of quadratics. So there are multiple forms which quadratics can be in. One form is ax squared plus bx plus c equals 0. Now, notice how I boxed ax squared plus bx plus c. This is the standard form of a quadratic, and a quadratic in general has a degree of 2, which means that the highest exponent that an x can have is 2, and this is shown here. Now, setting it equal to 0 means we can find these certain x values so that it works, where if you plug in that x value into that ax squared plus bx plus c, it'll spit out 0. If you see on the graph of of a general quadratic function, the zeros are where they touch the x-axis, as their y value coordinate is 0. Another form is vertex form. This vertex form is given by the general A, which was given in the standard form, and H and K. H comma K is the vertex, or it could be maybe considered as the maximum or minimum, depending on the graph. In this case, it is the minimum, as we see that our vertex is on the bottom. And then lastly, another form we could see a quadratic in is in terms of the zeros. x1 and x sub 1 and x sub 2 are zeros in this case. And this is how we can figure out the zeros, as we just set these factors equal to 0. Now we're going to be going into the factoring of simple quadratics. One example that I have here is x squared plus 7x plus 10. Now, how do we approach this problem? We're going to be using a method known as a diamond method. This diamond method is very common when you start learning quadratics. On the top of the diamond, we have the value 10. 10 is given by c in the standard form of the equation, and this is equal to, and because our a value is 1 here, this is equal to the product of the two roots or zeros that we're going to get out of this. On the other hand, 7 is on the bottom, and this is b, and in this case, this is the sum of the two roots. Now, we have to find out what multiplies to 10 and adds up to 7. We don't necessarily know if they're going to be nice integers or whole numbers, but in this case, because it's an introductory example, we can assume that they're going to be. And if we think, we will get 5 and 2 will work, because 5 times 2 is 10, and 5 plus 2 is 7. Therefore, we can put it, because our a value is 1, we can put it in this form, x plus 5 times x plus 2. And that is our factored form, indeed, of x squared plus 7x plus 10. If we set this equal to 0 now, we can find the zeros to be a negative 5 and negative 2. And if you graph this, you could see closely that at negative 5 comma 0 and negative 2 comma 0, it touches the x-axis, which means that they are zeros, roots, or x-intercepts. There are multiple ways to express them. Now, we did that when the a, or whatever is the coefficient in front of the x squared, was 1. But what about if it's not 1? Now, we could just think of the diamond method again, but we would also have to account for the fact that we're multiplying one of those, when you can't just simply say that they add up to some number and they multiply to some number, because we have to account for the fact that a is not 1, and that actually affects how the foiling method works out. Remember, foiling is just the opposite of factoring, where you're going from example x plus 5 times x plus 2 to x squared plus 7x plus 10. So what do? Well, we're going to do a method where we take the coefficient of x squared and move it over to the c value, or our constant. We're going to take it out and multiply it there. So now we're going to get it where it's x squared plus x minus 12. Now we have it in the form that is where a is equal to 1, and this is what we previously just did. We can use the diamond method again, but this time you must remember there is a negative in front. So we need to know that it multiplies to negative 12 with two roots, but they also add up to 1. And if you think for a bit, you'll figure out that it'll be some nice integers as you get 4 and negative 3. You could put this once again in a form where it's x plus 4 times x minus 3. However, this cannot be a right answer, because if you FOIL this out, we do not have an a value that is 1. It must be 2 according to the original thing. So what you must do is that 2 that you moved over to the constant, you have to divide both the outputs of the diamond method by. So we have to do 4 divided by 2 and negative 3 divided by 2. Obviously, 4 divided by 2 is 2. But 3 divided by 2 is 1.5, and that's not really nice. And we cannot keep it in a way where it remains as 1.5. And therefore, you must move the 2 over and the 2 over to the x, so it becomes 2x minus 3. So the root is still 3 over 2, but it is not expressed as x minus 1.5, but rather 2x minus 3. And now, if you FOIL this, you'll figure out that this is equal to x squared plus x minus 6. Once again, we're going to see what happens when we set it to 0. We're given that our roots, which we kind of already given, is negative 2 and 3 over 2. And if you graph this, you could see, it's a little bit small, but you can see that at negative 2 comma 0 and 1.5 comma 0, this graph touches the x-axis, and therefore there are x-intercepts, zeros, roots, whatever way you want to say it. Lastly, I'll be going over the quadratic formula. This is a quick table showing the justification of the quadratic formula. As shown, we start with the standard form ax squared plus bx plus c. And as you go down the proof, you will get into a solution where we see that the x, or the root of the equation, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And the proof has to do with some completing the square, transforming that original standard form so that a is equal to 1, and using completing the square so that we can effectively figure out what x is on its own. We're going to be using the same expression that we used when we did the previous example when we were factoring when a was not 1. 2x squared plus x minus 6. We're given that a is equal to 2, b is equal to 1, and c is equal to negative 6. So we can plug this into that quadratic formula, which must be memorized by all students. And remember, we will get 2 roots out of this because we have a plus or a minus. So there's going to be 2 solutions. The only time where you're going to have 1 is when that square root inside that square root is at 0. And because plus 0 and minus 0 are the same thing, and there's also a possibility that whatever in that square root is negative, and therefore it does not exist in the real world, and we won't have any real roots, but rather complex roots, which has to do with imaginary numbers. So, and then when you do this, you get x equals 1.5 and x equals negative 2. These were the same solutions that we did get in the previous method. Now, even though this wasn't directly factoring, we can put it once again into that same equation. And all we have to do is, because we have 3 over 2, we could just move the 2 over, and finally we get 2x minus 3 times x plus 2. So this is another way to factor. So there are multiple ways to factor this. And those are all 3 methods that we're going to learn for today. Thank you for watching this video. Please subscribe to the World of STEM for more STEM-based videos in mathematics, physics, chemistry, and computer science. See you next next time. Bye bye.